All right. Hello, folks. Thank you for the great introduction. I'm Angelica. These findings come from my first chapter from my dissertation, so I'm excited to get to talk to them about all of you. So as everybody knows in this room, web surveys are increasingly popular for a variety of reasons. They're cheaper than face-to-face and telephone interviews for the most part, and they can collect novel data for analysis. However, the issue with these web-based surveys is that the issue with these web-based surveys is that it requires respondents to all have access to the internet. And previous studies have shown that web-enabled surveys have exhibited coverage error bias due to these reasons. So specifically, they underrepresent individuals who have low education, lower income, and a variety of other characteristics. But beyond web surveys, smartphone-based surveys are also becoming increasingly popular, as we were just talking about earlier. These smartphone-based web surveys can collect novel data such as geolocation data, real-time pictures and videos from respondents, and more. But again, we have that same issue that not everybody has these devices. So currently, the statistics that you hear flying around are that around 90% of the US population owns a smartphone device. And these individuals who own smartphones do vary on many characteristics compared to those who don't own smartphones, specifically age, education, and income. However, despite these issues, there's very little research that assesses the coverage error bias implications of this underrepresentation of certain individuals due to not owning a smartphone. And further, there's very limited research that assesses this from a regression framework or assessing smartphone coverage over time. So that's what this study aims to do. So I have two research questions. First, I'm assessing whether there are differences in the characteristics of those who do and do not own smartphone devices. And the second research question is, how has smartphone ownership in the US changed over time and differentially over different groups of people? So to understand why somebody may or may not own a smartphone device, I use the innovation diffusion theory model, which comes from marketing research, which states that people choose to adopt novel technologies under 5 different steps. So first, the person has to learn about this technology. They then have to form an opinion on the technology. They have to make a decision as to whether they want to adopt or reject these new technologies, implement that decision, and then finally an optional step to seek confirmation with others about that decision that they made. And so the first thing that I expect is that people who have a greater visibility and exposure to smartphones in their surroundings may be more likely to own a smartphone. And this is linked to that first step in the innovation diffusion theory model, where people are gaining that knowledge about these devices. So for instance, those who are in urban areas, densely populated areas may be more exposed to smartphone technology just due to being around more people compared to those in rural areas. So that's what I would expect in the data, for instance. Additionally, I expect for people who have a greater utility for smartphone devices to own smartphones at a greater rate, and this is linked to forming an opinion about the technology. Conversely, those who have technophobia, which is the fear of technology for a variety of reasons, may be less likely to adopt a smartphone device. So for instance, those who are employed full-time may have a greater functionality for smartphone features compared to those who aren't employed. And those who are of an older age may be less familiar with technology and may be hesitant to adopt a smartphone for that reason, linking that to that technophobia mechanism. And then finally, there's a logistic reason of people not owning a smartphone, and that is not having enough income to do so. So I expect for the smartphone cost feasibility to be a reason for people to not adopt a smartphone, which is linked to that fourth step in the innovation diffusion theory model, that ability to actually implement their decision to adopt these smartphone technologies. So I use 2 data sets to answer these research questions. The first comes from the American National Elections Study, the ANES. This is an ABS sample of US adults. And I use data from the 2012, 2016, and 2020 implementations of the ANES, which is when they began asking about smartphone ownership in the United States. And then the second data set we should all be familiar with at this point is the Understanding America study. So in this study in 2014, they began asking about smartphone ownership along with many other devices. And the most recent data collection on smartphone ownership was actually last month, February 23. And so I chose the two endpoints, 2014 and 2023, to assess my first step into understanding smartphone ownership using the UAS data, while also acknowledging there are many waves in between those two endpoints that I will in the future add to my analyses. So my dependent variable for this study is smartphone ownership, which is dichotomized into owning or not owning a smartphone device at the time that the survey was collected. And then I have various indicators for the mechanisms I mentioned previously. So the indicator for visibility and exposure to smartphone devices is urbanicity, household internet access, as well as living alone or not living alone. I use employment status to proxy the utility of smartphone devices. Age and gender are proxies for technophobia. And then the smartphone cost feasibility is proxied with income. I also use the survey year in order to assess that change over time in smartphone ownership. So then moving on to my methods, I use binary logistic regression models to predict smartphone ownership. So I start off by just gathering a baseline predicted probability of smartphone ownership by just including my control variables. And then I add in the survey year as an indicator to assess that change over time for all respondents. After that, I include my various indicators to assess differential smartphone ownership for different categories of folks. And then finally, I include 4 different interaction terms separately in order to assess change over time for different groups of people, which I'll get into in a bit. So now moving on to the results for that first research question, essentially who does and who doesn't own a smartphone. So to orient you with what I'm going to be presenting here, these are bar graphs that show you the predicted probability of owning a smartphone device from the average marginal effects of my logistic regression models. And so if there is a star over the bar, that tells you that it is statistically significant and an alpha of 0.05 compared to our reference category, which is always going to be the first bar in each bar graph shown. So the first thing that you see here is whenever you're looking at urbanicity, that I initially expected for urban folks to have a greater likelihood of smartphone ownership compared to rural folks, but that actually isn't what I found. Interestingly enough, it was the suburban folks who had a greater likelihood of owning a smartphone compared to urban folks, but again, no differences there between urban and rural folks. Additionally, I did find that those who don't have access to household internet, excluding mobile access to internet, were less likely to own a smartphone compared to those who do have access to household internet. And in both the UAS and the ANES data sets, living alone was not a significant predictor of smartphone ownership. And so in this case, the visibility of smartphones is only inconsistently associated with smartphone ownership. So then going on to the utility of smartphones, I find that employed individuals and students are both equally likely to own smartphones. And compared to those employed individuals, unemployed individuals and retired individuals are less likely to own a smartphone device. So again, we see very similar patterns compared to the coverage error literature in web access. Going on to age, I find that in both data sets, older individuals are less likely to own a smartphone. And this is a difference of about a 10 percentage point difference between those who are older than 60 or 65 or older compared to those younger than 65. So we have a lot less coverage over with those older folks with smartphone ownership. And then whenever I look at gender, I find inconsistent results. So in the ANES data, gender was not a significant predictor of smartphone ownership, but in the UAS, women had a greater likelihood of owning a smartphone compared to men. So either way you take these findings, they didn't corroborate previous literature regarding gender and technophobia. So in this case, gender is only inconsistently associated with smartphone ownership. And then finally, moving on to income. I found that income was a positive predictor of smartphone ownership, which you can see with both of these line graphs here with the positive slope indicating that as somebody's income rises, so does their likelihood of owning a smartphone device. So again, higher income being associated with a greater likelihood of smartphone ownership. So now that we know who does and who doesn't own a smartphone, we're going to move into the results about differential change over time. So first, I found just across all respondents that smartphone ownership did increase over time. So you can see in the ANES, as early back as 2012, initial smartphone ownership rates were only around a little bit less than 50% in the US population. In the UAS, this was a bit higher for the baseline probability of smartphone ownership at around a little bit lower than 80 percentage points. But in both data sets, you see that climb to that around 90% statistic that we see from sources such as Pew. So there is an increase in smartphone ownership in the US population. But now, how does this differ across different groups? So first, this is the assessment in change over time for urban, rural, and suburban individuals. And what I first find is that there's no difference in growth over time for urban versus rural individuals or for urban versus suburban individuals. However, the rural adults grew in smartphone ownership in this earlier time period in the ANES data set from 2012 to 2016 faster in comparison to suburban adults. So you can find that with that red line increasing with a higher slope compared to the suburban orange line. So although this isn't something that I had predicted in advance, there was an exacerbated growth in those rural folks in those early years. Now, whenever you're looking at these changes over time by living alone, so this initially wasn't a predictor of smartphone ownership to begin with, but we do see differential growth over time for these groups of people. So specifically, those who live alone had increased growth over time in the early years of the ANES, and there was a significant change over time in the UAS data, showing that individuals who live alone have an increased growth over time in smartphone ownership compared to those who live with other people in their household. And then if we look at age, we find similar things. So in the ANES data set, in those later years, 2016 to 2020, we find exacerbated growth with folks who are 65 years or older compared to those who are younger than 65, indicating that they're essentially catching up to the younger folks in their smartphone ownership over time. But this is happening in a later period of time than what the other interactions were showing. We additionally find similar results in the UAS data set showing that those older folks are catching up to their smartphone ownership over time. And then finally, whenever we look at how income affects this change over time, we see very similar results. So lower income individuals have an exacerbated growth over time in smartphone ownership compared to higher income adults. And we see this similarly in the UAS data set, indicated by those lower income folks having a sharper positive increase over time. So again, we're seeing those folks who initially had those lower likelihood of smartphone ownership catching up to those who had those higher rates of smartphone ownership over time. So then in sum, what I found with this study is that smartphone owners are more likely to be younger. They're more likely to have a higher income. They're also more likely to be employed or be a student, to live in suburban areas compared to urban areas, and have household internet access. So this is very similar to the findings we see with web coverage in the US. Smartphone ownership did not or only inconsistently differed by urban versus rural status, living alone versus living with others, and by gender. So we have no really substantial differences there. And then smartphone ownership was found to increase over time, and that this was dependent on a myriad of other characteristics, including living alone, age, and income. So then what does this actually mean? So a sample of only smartphone owners or a survey that's only conducted on a smartphone device will underrepresent individuals that we care about. So this could underrepresent individuals who are older, who are lower income and unemployed, as well as individuals who don't have household internet access. And so this may lead to coverage error bias in our survey estimates. And this is something that is my next step in my dissertation, is to actually assess those the degree of coverage error bias in these smartphone exclusive surveys. Additionally, I did find differential growth over time in smartphone ownership, and this indicates that those lower coverage populations, so those older folks, the lower income folks, are essentially catching up to the higher probability of smartphone ownership for over time. And so this is good news. This means that in the future, there may be less coverage error bias in those estimates on smartphone only samples if these trends continue to follow over time. Thank you all so much. And I'm excited to hear all of your answers.